a revolutionary new study. It revolutionized our traditional understanding of black holes. For a long time, we rely on the Kerr-Well model to understand black holes, especially spinning black holes. But the latest findings suggest that these cosmic behemoths may be far away, more dynamic and chaotic than we previously imagined. This discovery could revolutionize black hole physics and uncover new secrets of cosmic giants for us. In this video, we will explore the significance of this research, how he challenges our understanding of black holes, and what it means for the future of astrophysics. Let's get started. Let's start with the basics. For decades, the Kerr model has always been the solution in astrophysics. Released black hole, in particular, the preferred model for rotating black holes. So what is Sister Kerr? Why is he involved in black hole theory? Such an important position. So, in a nutshell, this model is Einstein, a junction of the equations of general relativity. He did it with precision and elegance. It describes a rotation. Black holes are modeled after physicist Roy Kerr's name. He came up with this model in the 1960s. Kerr-Well black hole, described as an object with two different worlds. One is the outside world. There's nothing there. Not even light can escape. The other is the inner world, surrounded by a circular starting point. The starting point is a point where space-time completely collapses. What's so important about this model? Because he is matching practical observational aspects of black holes, it was very successful. Black hole images taken from the Event World Telescope to the attractive force wave detected by LIGO, most of the phenomena we observe, consistent with the predictions of the Kerr model. This provides us with a solid framework to explain the behavior of black holes without having to adjust our understanding of physics, the basic understanding of, at least until now. The core assumption of this model is stability. He described the stable structure of black holes over time, assuming they keep consistent core and predictable geometry. Shape this hypothesis enables scientists to use a reliable framework to simulated black hole, mainly concerned with what happens outside the black hole, rather than his inner workings. However, he has always had his limitations. Although well done at describing the outside of a black hole, but for the interior, very little is said about what might happen. This is where new research findings begin to challenge our long-term, the place where beliefs are held. Recently, it is composed of universities including southern Denmark and Italy. Plugged scientist. The research conducted discusses what goes on inside a black hole and show these objects may not be nearly as long as we are, stable as long believed. They launch inside the black hole, discovered some extraordinary things. Energy doesn't stay static. They accumulate over time. This leads to a phenomenon called dynamic instability. And the simple answer is this: the energy of the inner region of a black hole can be determined by number and growth, may cause fundamental changes in its internal structure. Imagine that. Inflate a balloon that is constantly expanding and deforming. This is according to research. What's happening inside a black hole? Why is this instability so important? So let's start with this. He fundamentally challenged black holes as stable, the idea of predictable objects. On the contrary, these findings suggest that black hole, it's a lot more dynamic and chaotic than Sister Kerr described. As time goes by, accumulated energy may be distorted from within structure of black holes, altering the entire geometry. This is not just a minor adjustment. He might mean black holes may not persist during their lifetime. The ridge of the Kerr ridge and shape studies, evidence of instability from the analysis of Misner. The quantity of genre, he described the mass and energy distribution through detailed calculations. Researchers have shown that the energy inside a black hole may not remain stable. They grow to extremes, ultimately affecting the shape and structure of the black hole. Stable Kerr model. For a long time, the scale becomes an inaccurate description, but it's more interesting here. If these instabilities are real, they may mean black holes will eventually deviate from the predictions of general relativity. This may be beyond the new physics of Einstein's theory. Opened the door. Possibility and quantum mechanics or other advanced theories. The impact of this study shows that our understanding of black holes, even the understanding of space-time itself, it may be on the verge of a major transformation. This study, one of the most exciting effects, is the potential for new theoretical models. For example, quantum attractive force theory, such as quantum attractive force or apparent theory. What might happen inside a black hole? Alternative explanations are provided. These theories suggest that black holes may have a complex structured core rather than a starting point. This will be related to the research. The findings of internal instability are consistent if black holes are indeed more structured inside. The quantum attractive force model can provide. Understand their missing context. Another important area to consider, non-Kerr black hole model. The hairball model in apparent theory. Different from assuming a smooth static structure. These models propose black holes may have complex fluctuating interiors. This could be related to the black hole discovered by the new study, probably more like a dynamic entity rather than static entities. If black holes are inherently unstable, this means that their true nature is far greater than mine. They think it's more complicated. And finally, this research also has interdisciplinary implications. Understand these instabilities may require astrophysics, combination of quantum mechanics, and advanced computational methods. This could lead to new collaborations across fields to break through our current understanding of physics. Pave the way. Thanks for watching. Please leave your comment for discussion.